Hello everyone, myself Mohit Gangwar. This is my project video for the lab course ELP101. I have chosen the topic of wave generator circuit using op-amp. So what are the waves we are discussing in this video? I will be discussing about a triangle wave generator and a square wave generator circuit using the op-amp. The representation of both the waves is as shown in the diagram. The triangle wave consists of a constant rising slope followed by a constant falling slope and resembles a poorly drawn mountain range. While the square wave function is a periodic waveform consisting of instantaneous transitions between two levels, minimum and maximum. In an ideal square wave, these transitions are instantaneous. First, let's focus on the triangle wave generator. Components of a triangle wave generators are a op-amp LM358, 3 resistors of 1 kilo ohm, 1 resistor of 10 kilo ohm, and a 1 resistor of 100 kilo ohm, a ceramic capacitor of 1 nanofarad, and an electrolytic capacitor of 1 microfarad. This is the pin configuration of LM358. LM358 is a dual noise operational amplifier which has two independent voltages comparators inside. When the voltage at the non-inverting input positive is higher than the voltage at the inverting input negative, then the output of the comparator is high, and if the voltage at the inverting input negative is higher than the non-inverting input positive, then the output at the comparator is low. This is how LM358 looks in real world. This is the complete circuit diagram of a triangle wave generator. This circuit is an example of relaxation oscillator using a single op-amp as a comparator. Initially, let's assume that the capacitor is discharged. Due to this, the voltage at inverting input is lower than the non-inverting input, which is half the supply voltage from the resistor divider. The output goes high till the capacitor voltage goes above the half the supply voltage. At this point, the inverting input is greater than the non-inverting input, and hence the output then goes low, resulting in discharging of capacitor. At the same moment, the resistor 10K acts as hysteresis. Means when the output goes low, the bottom leg of the voltage divider now has 1 kilo ohm and 10 kilo ohm in parallel, which decreases the overall resistance and reduces the reference voltage. The output of the op-amp is then AC coupled to produce a signal that has an equal positive and negative swing. To get the signal of a required frequency, the value of hysteresis resistor, the resistor divider are changed accordingly. And in order to get a desired amplitude, the output signal can be easily amplified. So this is how a simple triangle wave generator is built using a single op-amp. Moving to the second wave generator, that is a square wave generator. The main components of a square wave generator include a op-amp IC LM741, 3 resistors of 10 kilo ohm, a 9 volt supply, and a step-down transformer capable of reducing 230 volts to 12 volts. This is the pinout diagram for LM741. As we see that it has an inverting input minus and a non-inverting input plus. The output in this case is taken by pin 6. This is how IC LM741 looks. This is the complete circuit diagram for the square wave generator. A 230 volt supply is given to the transformer and its phase output is connected to the second pin of op-amp, and the neutral one is short with the ground of the battery. The positive terminal of the battery is connected to the 7th pin of the op-amp. In this circuit, the non-inverting terminal of the op-amp is connected with the ground as a reference voltage, and a sine wave input is provided to the inverting terminal of the op-amp. This input voltage is when compared with the reference voltage. The work of the transformer is to reduce the very high voltage, which is 230 volts AC, to a lower one so that we can operate on it easily. Now let's consider the positive half cycle of the sine wave input. We know that when the voltage at the non-inverting end is less than the voltage at inverting end, the output of the op amp is low or of negative saturation. Hence, we will receive a negative voltage waveform. Secondly, now consider the negative half cycle of the sine wave input. The voltage at the non-inverting end in this case becomes greater than the voltage at inverting end, and so the output of the op amp becomes high or of positive saturation, and hence in this case we will receive a positive voltage waveform. So this is how a square wave function is generated using a single op amp. Here is an interesting application of the square wave generator. That is, the square wave generator is used as a zero crossing detector. It is used to track the changing in sine waveform from positive to negative or vice versa, or when it passes the zero voltage. Is it clear from the shown diagram that whenever a sine wave crosses zero, the output of op amp changes either from negative to positive or positive to negative. It changes from negative to positive when the sine wave function changes from positive to negative and vice versa. In this way, the square wave generator can act as a zero crossing detector which detects the waveform crossing zero every time by changing its value. Zero crossing detector has many applications like time marker generator, phase meter, frequency counter, etc. Thank you.